Very good afternoon. See here, I am starting the session. Listen. So the previous session, we discussed about exception handling. In the exception handling, very clearly we discussed about rise application error, pragma exception in it. With that exception handling, chapter is over. Now see the next chapter and very important chapter. Okay, for Java developer or Python developer or PLSQL developer, these procedures, functions, topics are very important. So topic name is stored procedures. What is procedure, sir? See, you already know in C language. See here. In C language, we are using function concept. What is function? In the function, what you are defining? Statements you are defining. So function is a set of statements. Okay, in Java, you are calling as the method. Instead of class, if you define, we call method. Out of the class, if we define function. Inside of class, if we define, that is method. So in Java, we are calling method. So what is method? Method is a set of statements. So in C, we are calling function. In Java, we are calling method. Whereas in our PLSQL, we are calling them as the procedures and functions. So in PLSQL, procedure is also a set of statements. Procedure is a set of statements. Okay, so when it gets executed on calling. We have to call that one. Then only that procedure code will be executed. So when we call the procedure, then only it executes the code. Otherwise, it will not execute the code. So simply you can say, in the starting sessions, we discussed that there are two types of blocks. In the introduction sessions of PLSQL, we discussed this one. Okay, what are those? Named block, anonymous block. Anonymous block and named block. Anonymous block means block without name. Block without name is called a block without name. Block without name is called anonymous block. Okay, named block means a block with the name. A block with the name. A block with the name. So this procedure is a named block. It has a name. And block means in the block we are defining set of statements. So what is procedure means? Procedure is a named block of statements. Procedure is a named block of statements that gets executed on calling. That gets executed on calling. So we have to call the procedure. Then only procedure code will be executed. Okay. For example, see here. C # batch 2 p.m. Nourish IT. I'm setting server output on. Okay, I'm setting verify as off. Okay, observe carefully here. I'm writing like this. Begin dbms underscore output dot put underscore line. Hello, I'm writing. Okay, end / I'm writing. Now, what is the output of this program? Hello is the output of this program. Okay, now you tell me in this example, what is this put line? What is this put line here? What is put line? Sorry. From these many days we are discussing PLSQL. What is put line? Put line is a procedure. So here we are calling put line procedure. Here what we are doing, we are calling the put line procedure here. Okay, put line is the procedure here. But this procedure directly not defined. This procedure defined inside of package. Here what is DBMS underscore output? Package. So DBMS underscore output is the package. Put line is the procedure. So package name dot procedure name, we are passing the argument which we want to print. So here we are calling the procedure. So put line procedure we are calling to print the data. Just like in the C language, to print the data, you are calling printf function. Just like in the Java, you are calling println method. System.out.println hello you are writing. Here you are calling println method to print hello. Here you are calling printf function to print hello. In the same way, in our PLSQL, to print hello, we are calling putline procedure. What is putline, sir? Putline is the procedure. This putline is the procedure. So this PLS Oracle developers defined one procedure like this. Putline, with putline name, with some argument they defined. And they defined some code here. We are calling this procedure that is executing this code to print hello. So putline is the procedure. In that some statements are there. Oracle developers defined some statements in the putline procedure. We are calling that procedure here. So procedure gets executed on calling. But this is not stored procedure. This is packaged procedure. Instead of DBMS underscore output package they define. So in every procedure we define some statements. Those statements gets executed on calling. Just like to print the data on output screen, we are calling the procedure putline procedure here. So putline procedure we are calling. So Oracle developers already defined putline procedure here. By taking some argument, they have written some set of statements here, some code they have written in this procedure. So this procedure we are calling here. So procedure will be called, this code will be executed. So procedure gets executed on calling. So in the procedures, two types out there. There are two types of procedures. First one is stored procedure. Second one is packaged procedure. There are two types of procedures. First one is stored procedure. Second one is packaged procedure. So stored procedure means if procedure is directly defined, okay, or you can say procedure is a database object. This procedure is a database object like table, view, index, synonym. This procedure is also one database object because it is physically existed in the Oracle database and it is having name, and in that procedure we are defining some set of statements. So you can say it is the named block of statements. When these statements get executed, when we call it. So there are two types of procedures. First one is stored procedure. Second one is packaged procedure. If procedure is directly defined in schema, if procedure is directly defined in schema, then it is called stored procedure. If procedure is directly defined in the user, in the schema, then we call that as the stored procedure. For example, our batch schema is C hash hash batch 2 p.m. So in this schema, we are defining a procedure, addition procedure we are defining. So this procedure is called stored procedure. So if procedure is directly defined in the schema, that procedure is called stored procedure. In the C hash hash batch 2 schema, this addition procedure defined. So if procedure is defined in the schema, we call that as the stored procedure. Okay, next, packaged procedure. If procedure is defined inside of package, if procedure is defined in a package, then it is called packaged procedure. So if a procedure is defined inside of package, that is called packaged procedure. For example, C hash hash batch 2 p.m. is the schema. Inside of schema, directly procedure not defined. Here one package defined. My math package defined. Inside of this package, addition procedure defined. So now this is the procedure directly not defined. This is the procedure defined inside of package. So if procedure is defined inside of package, we call that as the packaged procedure. So observe the difference here. Here addition is the procedure. Addition procedure we are defining in C hash hash batch 2 p.m. In the schema, if procedure directly defined, we call that as the stored procedure. In the second example, here C hash hash batch 2 p.m. is the schema. So now this procedure not directly defined in the schema, this procedure defined in the package. In the schema, package defined. In the package, procedure defined. This is called what? If you don't have interest, please don't come. Okay, so many students are not coming. We are in the ending only. Within 2 weeks I finish. If you don't have interest, please don't come. You are here means please give the response here. So, how many types of procedures are there? What are those? What is stored procedure? If we define the procedure directly in the schema, that is stored procedure. Here C hash hash batch 2 p.m. is the schema. Inside of that schema, we are defining the procedure. Okay, this is called what? Stored procedure. Packaged procedure means what? If the procedure defined in the package, here addition procedure defined in my math package defined in batch 2 p.m. schema. This is called packaged procedure. Okay, so now you tell me, you already know put line procedure. Is put line procedure stored procedure or packaged procedure? Packaged procedure. How you are telling that one? To call that you are using dbms underscore output dot put underscore line. Okay, so here put line is the, in this, put line is packaged procedure. Put line is packaged procedure. Okay, so here what is this dbms underscore output? Package. So dbms underscore output is the package. Inside of the package, we are defined, Oracle developers defined this put line procedure. So to call this, package name dot procedure name be used. Okay. In the same way, in the materialized view, we discussed about one procedure. In on-demand way, to refresh the materialized view, we use refresh procedure. Okay, so if you want to use this put line, you are writing like this, dbms underscore output dot put underscore line, hello. So here we are calling putline procedure here. Here we are calling putline procedure, which is in the dbms underscore output package. In the same way, to refresh the procedure, to refresh the materialized view, we are using one procedure, refresh procedure we are using. Okay, this refresh procedure, is it packaged procedure or stored procedure? This is packaged procedure only. Maybe you didn't practice, or maybe you forgot. So you are learning the subject and you are forgetting the subject, means you are wasting your time in Amirpet. dbms underscore mu is the package. Refresh is the procedure. To refresh the procedure, to refresh the materialized view in the on-demand way, we call the refresh procedure. There I explained this one. So in this example, what is refresh here? Refresh is the packaged procedure. What is this dbms underscore mu? This is a package. So inside of the package, it is defined. Inside of dbms underscore mu package, it is defined. So that's why we are calling this as the packaged procedure. Okay. So in the packages chapter, we discuss about packaged procedures. In this chapter, just we discuss only stored procedure only. Okay. So Oracle developers defined one procedure, mu, and in this they defined some code for refreshing materialized view. And this procedure defined in one package. That package name is dbms underscore mu. So the dbms underscore mu package, they defined this procedure. Okay. So here dbms underscore mu dot refresh, we pass the materialized view name which we want to refresh. So here we are calling the procedure. It passes MB1 name here and execute this code. So every procedure is having some set of statements. That code will be executed with this calling statement. So here we are calling refresh procedure to refresh materialized view MB1. Because of it is packaged procedure, we are using package name dot procedure name. So in the refresh procedure, they define some code. This code will be executed. So procedure gets executed on calling. So what are the advantages we are getting with procedures? So in this chapter, we learn only stored procedures. Chapter name is stored procedures. Packaged procedures, I explain in the packages chapter. So what is procedure? Procedure is a named block of statements that gets executed on calling. In the procedure, we define some set of statements. When we call that procedure, that executes the code. So what are the advantages we are getting here? First advantage is it provides modularity. Modularity means one programming style. Modularity means one programming style. Modularity means it is programming style. So we divide large program into small parts. That style is called modularity. So dividing large program into small parts. So we divide large program into small parts. So dividing large program into small parts is called modularity. So every small, in PLSQL, every small part is called procedure or function. In PLSQL, this small part is called procedure or function. So PLSQL program we write in the form of procedures and functions. Just like C program we write in the form of functions. Okay, C follows modular style. In the same way, our PLSQL program also follows modular style. So we are dividing large program into small parts. Every part we are calling as a procedure or function. So with modularity, advantages are modularity improves understandability. Modularity improves understandability. Because we are dividing large program into small parts. So we can understand code easily. If you write the code sequentially like this, if 50,000 lines code is there, if it becomes difficult to understand. Whereas this 50,000 line code, 10 lines I am writing in one procedure, 10 lines I am writing in one procedure, 10 lines I am writing in one procedure. Like this, if I divide, I have to understand only this part only. I can understand easily. Okay, but if you write 50,000 lines code sequentially, it becomes difficult to understand. So this style is called sequential style. With sequential style, lack of understandability problem is there. After certain stage, we loses control on the program. We cannot understand which code we have written for which purpose in a sequential approach. So to avoid that problem, they introduced this modular concept. So here we are dividing large program into small parts. Every small part we are calling as procedure or function in our PLSQL. So we have no need to understand entire project, entire code. Just understand this part, then understand this part, then understand this part, like this. So it improves understandability and better maintenance will be there. Okay, so better maintenance will be there. Tomorrow, if you want to add some more to functionalities, add one more procedure. Okay, if you want to add one more functionality, add one more procedure. So just we have no need to test entire project. Just to test this new procedure only. Just to test this new procedure only. Like this, better maintenance will be there. Assume that in the project 100 procedures are there. You want to add 2 more procedures. You have no need to disturb these 100 procedures. Simply define these 2 procedures, add here. You have no need to test these 100 procedures. Just to test these 2 procedures only. If this procedure concept is not there, even if you add 2 lines code, entire program, 50,000 lines code, you have to test again. Better maintenance will not be there. Okay, with modularity, better maintenance will be there. In sequential approach, no better maintenance, no understandability. Okay, no reusability. It provides reusability. You can reuse the code. Okay, this Oracle developer defined put line procedure for one time. In our codes, we used to put line procedure for many times. Reusability. Okay, and it reduces length of code. So Oracle developer defined put line procedure. Assume that he had defined 10 lines code. If this put line procedure is not there, to print hello every time we have to write 10 lines. Next, after some lines, if you want to print the data, again you have to write 10 lines. It increases length of code. If procedure concept is not there, procedure is reducing length of code. And this put line procedure they defined for one time. Till now we use it for n number of times. Reusability. So these are the advantages we are getting with modularity concept. Okay. And so like this, it improves the performance. Procedure improves the performance. How procedure improves the performance, sir? See here, try to understand. So this is a program. In the previous session, somewhere we defined this. So it's a program to add two numbers. Okay. Observe. I'm copying this. Okay. Observe. This is one anonymous block. Okay. When we type slash here, now this program is in high level language. Oracle cannot understand this. For Oracle understanding purpose, it is compiling and running the program. Now second time I am running. Again it is compiling and running the program. Third time I am running. Again it is compiling and running the program. So every time it compiles and runs. But whereas the same code, if you define in the procedure, procedure holds compiled code. Procedure holds compiled code. Okay, we have no need to compile every time. We have no need to compile every time. Just we run the procedure by calling. So automatically performance will be improved. This is one anonymous block. Here at SQL prompt, when you are typing slash, this code will be compiled and it runs. Second time I am running. Again this code will be compiled and it runs. If you use procedure here, procedure holds what? Compiled code. Just call this procedure. Just call that procedure. Okay, so when we call that procedure, this compiled code will run. So is it compiling every time here? No, directly running the code here. But anonymous block means every time it is compiling and running. For compiling it takes some time. If large amounts of code is there, it takes more time. Okay, procedure is holding compiled code. So every time it is not compiling, automatically some time will be reduced. So procedure improves the performance. Okay, so like this provides security. Only authorized users can call them. It provides security because all procedures and functions stored in centralized location, only authorized persons can use them. Only authorized users can use them. So it provides security. So like this, we are getting the advantages with the procedures. These are the advantages with the procedures. So what are the advantages we are getting with the procedure? First advantage is modularity. With modularity, it improves understandability. We can understand the code easily because we are dividing large program into small parts. Better maintenance will be there. Easily we can add procedures. Easily we can test them. It provides reusability. We are writing procedure code only once, but we can use that code for any number of times by calling. And it reduces length of code. If procedure concept is not there, every time we have to write that procedure code. And it improves the performance because every time it will not compile. It holds compiled code. Just it runs the code when we call it. And it provides security. Only authorized users can call them. So these are the advantages we are getting with the procedures. See, till now, in the first 3 chapters or 4 chapters, you learned coding, PLSQL introduction, control structures, cursors, exception handling. In these 4 chapters, you learned coding. Now, coding you already know. That code we write in the procedure concept. That's it. In this chapter, you are not learning coding. How to write the procedure you are learning. Coding you know now. In the first 4 chapters, you learn coding. From now onwards, you learn the concepts. That coding, how to write in the procedures. That coding, how to write in the functions. That we learn. So, this procedure has name. So, we are calling this as the named block of statements. When we call it, it gets executed. There are 2 types of procedures out there. One is stored procedure, another one is packaged procedure. Stored procedure means directly in the schema we define. Packaged procedure means instead of the package we define. In the batch 2 PM schema, in the by math package, addition procedure defined. Packaged procedure. In the batch 2 PM schema, addition procedure directly defined. Stored procedure. What are the advantages we are getting? It provides modularity. With modularity, it improves understandability. Better maintenance will be there. Provides reusability. Reduces length of code. Improves the performance. Okay, and provides the security. These many advantages we are getting with the procedure concept. Now see the syntax to define a procedure. So to define the procedure, what is the syntax here? Listen, this is important. We write like this: create or replace procedure. Then give the procedure name here. Create or replace procedure. Then give the procedure name. Procedure name we are giving. After that, give argument list. So argument list we are giving. Which arguments we want? That argument list we are giving. Okay. And here, specifying this argument list is optional. Based on our requirement, we give them. Then is or as. Is or as we write. Okay. After that, here we write begin. And in between that, we write the executable statements. If you want to declare any variables, after is or as, anyone you can write. After is or as, declare the variables here. Okay, so this is the syntax we have to follow. Don't use declare here. For declaring variables, don't use declare. Okay, after is, directly declare the variables. So this syntax we have to follow. Create or replace procedure. Procedure name we have to give. After that, if required, we give argument list. Then write is or as. If any variables are used in this code, those variables we declare here. And here we write the executable statements. By seeing this syntax, you can say that this procedure is having name, and in this you are defining some set of statements. Okay, so procedure is a named block of statements. When we call this procedure, that executes this code. So this is the syntax we have to follow. Observe the syntax. Now I define one procedure. Observe: create or replace procedure, procedure name, argument list, write is or as. Okay, here if required, declare the variables, begin, end, executable statements. So now my requirement is, I want to define a procedure to add 2 numbers. This is my requirement. So, in the C language, if you want to define a function in C or Java, if you want to define a function or method, You are giving function name like this. We want to add two numbers. Okay. So if you want to call, you are calling like this. Add of 5, 4. Like this you are calling. This is called function call. So here you are calling the function. To capture this 5 value, we take one argument here. To capture this 4 value, we take one more argument here. So to capture these two numbers, take the arguments. So add int x comma int y. Like this you are writing in the C language. Okay. So in the same way, see here. Here, what are int x, int y, xy are what here? Xy are called arguments. Xy are arguments here. Okay. Why we are using them? To get values into this function. To get values into this function, we are using it. 5 value will be passed to the x. 4 value will be passed to the y. Now what is the x value now? 5. What is the y value now? 4. We want to add them. So to add them, here you are writing the code. Like printf. Okay, sum equals to %d, comma, x plus y. Or you are holding that value in the z. And that z value you are printing. Like this you are writing. So the point to understand here is, here int x, int y, xy are called what? Arguments. To capture the values into this function, we are using arguments. In the same way, our procedure name is addition. Addition is our procedure. So we call like this, addition of 5, 4. In our PL SQL, you cannot take function name as add. You cannot take function name as add, because add keyword is there in the alter command. To add the column, we use this add keyword. And there is some built-in function is there. Okay, because of that reason, again you cannot take procedure name as sum here. You cannot take add, you cannot take sum. I am taking procedure name as addition. Our procedure name is addition. So we are passing 5 value, 4 value. In the C language, you are writing like this. Int x. What is int here? Data type. What is x here? Variable. This variable only we are calling as the argument. So in the same way, in our PLSQL, we write reverse. Okay. There first data type we are writing, then variable we are writing. Here first write variable, then write the data type. And remember, don't specify the sizes like this. Don't specify the sizes. For procedures or functions, don't specify the sizes. So x, y, number. Now what happens here? This 5 value will be passed to the x. Now what is the x value now? 5. 4 value will be passed to the y. What is the y value now? 4. That's it. This is the way here. What are x and y? X and y are called arguments. X and y are called arguments. Okay. And remember, don't specify any size here. So we are defining the procedure here. Create or replace procedure. I am giving procedure name as addition. What is the procedure name? Addition. Okay. We want to add 2 numbers. So take 2 parameters here. X, which type? Number type. Y, which type? Number type. Then write is or as. Okay. Then write begin. Then write end. Slash. Our requirement is we want to add 2 numbers, X and Y. That result I am holding in the Z. Declare Z here. Z is which data type? number data type. Here we can specify the size. Okay. Here we can specify the size. For arguments, don't specify the size. Remember. Don't specify size. Don't specify size in argument declaration. So in argument declaration or parameter declaration, don't specify the size. Okay. Don't write like addition of X number of 4. This is invalid. This is invalid. Okay. Write like this. Addition. Okay. X number. This is valid. Don't specify the sizes. Don't specify size like this. This is wrong. Don't specify the sizes. Okay, just use the data type only. Okay, if you give sizes, it gives error. So this is the way of creating the procedure. Observe here, create or replace procedure. What is the procedure name? Addition. What are the arguments here? X and Y. Okay, so X plus Y we are calculating. We are storing result in the Z. Okay, Z we are declaring. Now Z has some value. We want to print that one. So dbms underscore output dot put underscore line sum equals to Z. Okay, in the code, is anything new to you? In the code, is anything new to you? No. Everything you know here. This coding you know, coding you learn. That code we are writing in the procedure. That's it. Okay, this program already we did. How to add two numbers program we already did. That code only we are writing inside of the procedure. Okay, because we want to reuse this code. In the anonymous block, if you write, you cannot reuse that one. If you write like this, you can reuse. Okay, so here, this is the code. I'm copying this. Observe. I'm copying this procedure. Okay. What it is telling? Procedure created. So now procedure is created. What is that procedure name? Addition. Addition procedure is created. This procedure is having compiled code. This procedure is having what now? Compiled code. Compiled code is there. So this code we want to use. So we have to call this procedure. So how to call the procedure we have to know now. Calling a procedure. So we can call a procedure using 3 ways. We can call a procedure using 3 ways. 3 ways are there. What are those, sir? First way is from SQL prompt you can call. From SQL prompt you can call. Second way is from another PL/SQL program you can call. From another PL/SQL program you can call. Third way is from front-end applications you can call. From front-end applications. From front-end applications like Java, Python, okay, C#. From the front-end applications, okay, you can call them. Okay, so I explained 2 ways here. I explained 2 ways only. One is how to call from SQL prompt I will explain. And how to call from another PL/SQL program I will explain. If you are the Java developer, in the Java you will learn how to call this procedure. If you are the .NET developer, in the C#, you will learn how to call the procedure. If you are the Python developer, in the Python, you learn how to call the procedure. In the database connectivity concept, you learn this, how to call the procedure. So I am explaining 2 ways only. First one is from SQL prompt. From SQL prompt, how can we call? So if we want to call from SQL prompt, we have to use one command, exec command. or you can also write execute, or you can also write execute command also. Completely you can write. So exec command is used to call the procedure from SQL prompt. So from SQL prompt, if you want to call, we have to use one command. That command name is exec. Exec is one command. So exec command is used to call the procedure from SQL prompt. So we call like this, exec, call the procedure. See, observe here. Put line is the procedure or not? If you want to call from SQL prompt, use execute command. Because of it is packaged procedure, write like this, dbms underscore output dot put underscore line. Hello, I am writing. So this is calling from SQL prompt. If you write begin end, that is calling from PL SQL program. So this is calling from SQL prompt. Is it printing hello or not? Yes. Hello, it is printing. Here you are calling put line procedure from where? From SQL prompt. For this, which command we are using? Execute. So execute package name dot procedure name. So this is calling from SQL prompt. If you write like this, begin. Okay. So dbms underscore output dot put underscore line hello end slash. If you write like this, this is calling put line procedure from PL SQL program. Okay. So begin end is there means you're calling from PL SQL program. If you are using execute command means you're calling from SQL prompt. So if you want to call the procedure from SQL prompt, we use execute command. Execute command is used to call the procedure from SQL prompt. Execute. Which procedure we want to call? Addition. 5,4 I am giving. So what it gives now? Sum equals to 9. One more time I want to call. Second time I am calling. I am passing first number as 100. Second number as 200. So what is the sum value it gives now? 300. So whenever our requirement is adding two numbers, just call like this. Second way, from another PL SQL program. So this is called main program. Our procedure is the sub program. Our procedure is a sub program. So it can be also called as sub program. It can be also called as sub program. It is not complete program. It is part of the program. So we have to call this one from another PLSQL program. So from another PLSQL program we are calling. So this program we are calling as the main program. This program we are calling as the main program. From main program we have to call. Okay, observe here. We are writing like this. See, declare. This is main program. Anonymous block. Begin, end. I'm declaring I'm declaring A variable here, and B variable here, and C variable here. A is int type, B is also int type, and C is also int type. A value I want to read. B value I want to read. This A plus B I want to calculate now. So to calculate this A plus B, I'm not writing my own code. I want to call the procedure. Our procedure name is what? Addition. Addition of A I'm passing as first argument. B I'm passing as second argument. Okay. This result I am holding in the C. That C value, this is called procedure call. This is called procedure call. Here we are calling the procedure. Okay. So finally C has some value. dbms underscore output dot put underscore line. Sum equals to concatenation operator C. So this is the way. So when you run this program, it will ask enter value for A. Then it will ask enter value for B. Enter value for B. Okay, I'm giving A value as 10, B value as 5. It prints some value as 15. So we are not writing the code here. In this, for adding two numbers, we are not writing the code. Just we are calling the procedure. A value will be passed to X, B value will be passed to Y. There. For example, if we give A value 10, B value 5, this procedure code will be executed. So in the PLSQL program, you are calling like this. Addition of A comma B. Now A value will be passed to the X. B value will be passed to the Y. What is the A value we are giving? 10. What is the B value we are giving? 5. So now what is the X value? 10. What is the Y value? 5. It calculates 10 plus 5 value, 15 will be stored in the Z. On output screen it prints sum equals to 15. So procedure gets executed on calling. Here we are calling, it is executing the code. If we don't call, it will not execute. Procedure gets executed on calling. So this is the procedure we created. Now we want to call from SQL prompt. To call from SQL prompt, which command we have to use? Execute. Already procedure is created. Observe here. Procedure is already created. Procedure created. Okay, execute. Procedure name is addition. Okay, I'm giving first number as 20, second number as 30. Okay, 20 plus 30 value is 50. Procedure call executing. Observe here. So here we are calling the procedure. This is called procedure call. So procedure is called. X value becomes 20 there. Y value becomes 30 there. There X plus Y it is calculating. 50 it is calculating. Storing in the Z. Z value it is printing. So procedure code executed here. Okay. So we have written code for one time. Whenever our requirement is adding two numbers, just call this one. Okay. Now I want to add 100 plus 500. 100 plus 500 I'm calling. It is giving some value as 600. We defined code once. But we can use that code for any number of times by calling like this. Reusability. If this addition function procedure is not there, whenever our requirement is adding two numbers, every time we have to write the program. Every time we have to compile. Every time we have to run. Okay, here already in the addition procedure, compiled code is there. Just we are calling here. That compiled code it is executing. Okay, so this is the way of calling from SQL prompt. So here we are giving number. Okay, 1 comma 7, sum equals to 8. So this is the way of calling from SQL prompt. If you want to call from SQL prompt, use the execute command. From another PLSQL program we want to call. Just now we have written another PLSQL program. This is another PLSQL program. We are calling this as the main program. I'm copying this. It is asking a value. Sorry, maybe enter key pressed for 2 times. Just a minute. Okay, see here. A value it is asking. A value I'm giving as 1. B value it is asking. B value I'm giving 2. Okay, just a minute. No function with name. So how we call? Sorry, it is not written. Don't hold the value here. It is not returning, right? I'm sorry. It is not returning. It is not returning. Okay, so just call the procedure. That's it. Here we have no need to print. In the procedure only we are printing, right? This is not function. This is procedure. I'm sorry. So here, what we are doing, just we are calling addition procedure. A value 5 we are giving. B value 4 we are giving. So now this A value will be passed to X. B value will be passed to the Y. There only that is calculating 5 plus 4 value, and there only that is printing some value as 9. So procedure only printing the data. Is it required to print you again? Not required. Okay. So this is the code. I'm sorry. This is the code. This is correct code. Okay. Don't hold that value. Procedure is not returning. You cannot hold that one. Okay. So this is called a procedure call. I'm copying this. Okay. Observe here. A value I'm giving as 1. B value I'm giving as 2. What it is printing? Observe. Sum equals to 3. So procedure only printing this value. So in our PLSQL program, just we are calling. That's it. That procedure has only printing code. This procedure has only printing code. Just in the PLSQL program, you are calling addition function. One value will be stored in the X, 2 value will be stored in the Y. 1 plus 2 it is calculating, 3 value stored in the Z, Z value 3, that Z value it is printing. So already procedure is printing. Again we have no need to print in the procedure. So this is the way of calling from another PLSQL program. So this is about procedures. Now see, listen, there are, so is it clear till here? So what we did here, just we defined one procedure by using this syntax. So by using this syntax, addition procedure we defined here. This is the addition procedure. Create or replace procedure, procedure name addition, X, Y are the parameters, or you can say arguments. Okay, so here we are writing the code which we want to execute. When we call the procedure, that code we are defining here. So from SQL prompt you can call, from another PLSQL program you can call. From SQL prompt if you want to call, execute command we have to use. From another PLSQL program if you want to call, define another PLSQL program here. We are calling this program as the main program. Okay. Now listen, this is important. Topic name is parameter mapping techniques. Or you can say parameter association technique. Mapping, or you can say association. Parameter mapping or parameter association. Parameter mapping techniques, or you can say parameter association techniques. This is the topic name. Okay. So there are 3 parameter mapping techniques. There are 3 parameter mapping techniques. First one is positional notation. Positional notation. Second one is named notation. Third one is mixed notation. So these 3 are the parameter mapping techniques. One is positional mapping. Second one is named mapping. Third one is mixed mapping. 3 mapping techniques are there. So what is this positional mapping? Positional mapping means based on the position, parameter values will be passed. Based on the positions, parameter values will be passed. Parameter values will be passed. Okay, named notation means based on the names, parameter values will be passed. What is the meaning of this one? We have to learn. Okay, mixed notation means both will be there. Mixed notation means okay, based on positions and names. Based on positions and names, parameters will be passed. So to understand this, I am explaining one example. See here. Listen. Define a procedure to add three numbers. Okay, I am giving procedure name as addition. We want to add three numbers now. To understand this, what is this positional notation? What is name notation? And what is this mixed notation? To understand this, I am explaining this example. We want to define a procedure to add three numbers. Procedure name is addition. Take three arguments. Same previous example. There we added two numbers. Now we want to add three numbers. Okay, observe here. Create or replace. Okay, procedure. Procedure name. What is the procedure name? Addition. Okay, take three arguments. X number type, Y number type, Z number type. What we have to write here? X number, comma, Y number, comma, Z number. Then write is or as. Okay, then write begin, then write end, slash. What we want to calculate now? X plus Y plus Z, I am holding in the A. Declare A here. A is which type? Number type. Okay, we want to print A value. So what we are writing here? dbms underscore output dot put underscore line sum equals to A. For our understanding purpose, what is the X value? What is the Y value? What is the Z value? I want to know. So for our understanding purpose, I am printing X value here. So to print X value, X equals to will be printed there. X value we are printing. Concatenation operator. I want to get three spaces. Y value I want to print. So write Y equals to concatenation operator Y. Next I want to get three spaces. So give three spaces here. Z value I want to print. So write Z equals to concatenation operator Z. So X value we are printing. What it prints here? X equals to will be printed. If X value is 10, that prints 10 here. Next three spaces it will give. For example, Y value 20, Z value 30. Here what it prints now? Y equals to Y value will be printed 20. Next three spaces, Z equals to will be printed. Z value 30 will be printed. So like this, X value, Y value, Z value I want to print. That's why I'm writing this printing statement. Okay. Now what is this positional notation? Positional notation means we are calling like this. Positional notation means based on the positions, values will be passed here. We are calling like this. Execute. What is the procedure name? Addition. Okay, I'm giving 10 here. Next 20 I'm giving, 30 I'm giving. Now what happens here? This 10 value will be passed to the X. 10 value will be passed to the X. 20 value will be passed to the Y. 30 value will be passed to the Z. What is X value now? 10. Y value 20. Z value 30. So here it prints X value 10, Y value 20, Z value 30, sum equals to 60 prints. So first position value will be passed to the first position argument. Second position value will be passed to the second position argument. Third position value will be passed to the third position argument. Based on the position, parameters are mapped here. Mapping means association, linking. 10 value associated with X. 20 value associated with Y. 30 value associated with Z. First position value mapped with first argument. Second position value mapped with second argument. Third position value mapped with third argument. This is called positional mapping or positional notation. Based on the position, values are mapped here. For example, the same thing I am writing like this. Now say about name notation. Name notation means we pass like this. Observe. So in the name notation we call like this. at SQL prompt. So now here, what is the X value now? 10. What is the Y value here? 20. What is the Z value here? 30. And sum equals to 68 prints. Now, in the name notation, we are calling like this. At SQL prompt, we are calling execute addition of. Observe carefully here. Addition of. We are pausing like this. Addition of. See. Y value I am passing as 10. This is the way. So 10 value, if you write like this, 10 value will be passed to the first argument X. But this 10 value, I want to pass to Y now. I don't want to pass to X. First value, this 10 value, I want to pass to Y. So we have to instruct that one. Please pass this 10 value to the Y. Like this we have to tell. So here we are using the parameter name Y. We use this operator. Equals to greater than. Arrow operator we use. Equals to greater than. So Y value we are passing as 10. Okay. So next Z value we are passing as 20. Next X value we are passing as 30. So like this is called name notation. Based on the names, values will be passed here. So if we write like this. So if we write like this, what happens here? See, if we write like this, what happens? This 10 value will be passed to the Y. This 20 value will be passed to the Z. 30 value will be passed to the X. So based on the names, values are passed here. Okay, so like this, we can use name notation. This is called name notation. So X value it prints as 30, Y value it prints as 10, and Z value it prints as 20. So this is called name notation. Next, third one is mixed notation. So third one is mixed notation. Mixed notation means, okay, both will be there. Mixed notation means both positional will be there as well as named will be there. Okay, listen carefully. For example, addition of. Okay, I am passing like this. I am passing Z value here. Z value I am passing as 30 or 10. Okay, next I am giving 10 here. Next I am giving 20 here. Next I am giving 30 here. Now you tell me this 10 value will be passed to which variable? 20 value will be passed to which variable? It gives error. It gives error. Okay, why it gives error, sir? Because after named, you cannot use positional. After positional, we can use named. After positional, we can use named. But after named, we cannot use positional. So after named mapping, okay, we cannot use positional mapping. Okay, that will get confused now. Their order is X, Y, Z. So if this is passing this value to the Z, this second position value that has to pass to the Y or that has to pass to the X, that will get confused here. This is the problem here. Okay, then what about this 30? If this Z value is passing to the, this 10 value is passing to the Z, what about 30? This 30 has to pass to whom? That will get confused here. Because of this reason, that is giving the error. So after named mapping, we cannot use positional mapping. Okay. So for example, we are writing like this. Execute addition of. Okay. First value I am giving as 10. Next Z value 20 I am giving. Okay. Y value 30 I am giving. Now is it possible now? Yes, this is possible. So now it displays X value as, what is the X value here? 10. Okay, what is the Z value here? What is the Y? Sorry, what is the Y value here? 30. And what is the Z value here? 20. So like this, it prints sum equals to 60. So a named notation can follow positional notation, but a positional notation cannot follow named notation. Okay, let me show it. So as of now, we didn't create any procedure here. So first create the procedure. See here, this is a procedure for adding 3 numbers. Listen carefully here. What is the meaning of this create or replace? See here. If create means if procedure is not created, first time a new procedure will be created. So addition procedure already we created to add 2 numbers. So if I don't write this replace here, if you create the procedure, it gives error as procedure name already exists. Okay, so because of this reason, if procedure name is already exists, what we are doing now? Replace we are using. We should be careful when we are using this one. So if you use replace here, what happens? This adding 2 numbers code will be gone. This code will be replaced with adding 3 numbers code. So previous code will be gone here. So that is the meaning of create or replace. Observe here, already addition procedure created or there are created. Addition procedure is already created. Once again, I am trying to create addition procedure here. So now is it creating addition procedure? Observe here, name is already used, it is select. Here, am I using or replace here? No. Create procedure means it can create, but because of addition name already there, it is telling that name is already used. If you give different name, it creates. What is the meaning of create or replace here? Okay, if existing procedure is there with the name, okay, that code will be replaced with this code. The previous code will be gone. This new code will be placed there. That is the meaning of create or replace. So now adding 2 numbers code will be gone. This adding 3 numbers code will be stored. Okay, so now addition procedure is created. I am calling from SQL prompt now. I am calling like this. Okay, I am calling like this. See here. So procedure is created. Observe. So procedure is created. And remember one more point. Whenever we are creating the procedure, if any errors are there, it gives like this. Procedure created with compilation errors. Here the problem here is I didn't use semicolon here. So because of this reason, it is telling that procedure created with compilation error. So syntax mistake means compilation error will be there. Compile time error. Syntax mistake. So if you want to see that error message, which error is there, we don't know. To see that, write show errors. Show errors means it will display the error. So in the 8th line, some error is there, it is telling. So in the 8th line, some error is there. Okay. So we had to check before line and after line also. Actually here in the 6th line, semicolon is not there. That's why it is telling that error. So I'm correcting this one. Now procedure will be created. So if you want to see the errors, if any errors are there, it displays procedure created with compilation errors. To see those errors, what we have to write? Show errors. Remember this. So with this, you can identify in which line error is there. Okay, what is that error? You can read here. You can identify that one. So procedure is created. Observe. This is a procedure created for adding 3 numbers. We want to call from SQL prompt. So we are calling like this. Addition of 10, 20, 30. Now 10 value will be passed to the first argument x, 20 will be passed to the y, 30 will be passed to the z. Observe here, x value 10, y value 20, z value 30. Okay, now this one is which type notation? Is it positional notation or named notation or mixed notation? Positional. Based on the positions, these are mapped. First position value passed to first positioned argument. Next, for example, I am writing like this. Okay, z value I am giving 10. Okay, y value I am giving 20. X value I am giving 30. So now this first value will be passed to the third argument, z. Okay, the second value will be passed to the second one only. Okay, y value. And this one will be passed to the first argument, x. So x value 30, y value 20, z value 10. Okay, so observe here, x value 30, see here, x value 30 we passed, x value 30, y value 20, okay, z value 10. Based on the names values mapped, observe, this is named notation, named mapping. Next, third one, mixed. For example, I am writing like this, addition of. Okay, so first value to the x I am passing 10. Okay, next, second value I am passing to y, third value I am passing to z. Can we write like this? It gives error. So a positional notation cannot be followed by the named notation. So it gives that error only. Observe here, it is telling error. A positional parameter association, see here, a positional parameter association may not follow a named association. A positional parameter association may not follow a named association. This is the error actually we are getting. So the problem here is, this is the positional notation. These positional notations are following this named notation. This is not possible. That's why it is giving error here. A positional notation cannot follow named notation. Okay, first give positional, then give named. For example, we are writing like this. Okay, we are giving 10 value here. This is x value. After that, second value I am passing to the z. Third value I am passing to the y. Now, is it possible now? Yes, this is possible. A named parameter association can follow positional parameter association. Okay, so observe here, it is working now. X value 10. This is positional notation. First value passed to the x. This is positional notation. And second value passed to the z. Third value passed to the y. Okay, this is what named notation. So this is named notation. This is positional notation. Both are there. So because of both are there, we are calling this as the mixed notation. Okay, so here based on the positions, values will be passed here. Here based on the names, values will be passed. Okay, if based on the names it is passed named notation. If based on the positions it is passed positional notation. If both are there, we call that as the mixed notation. And this is not possible. Okay, a positional notation cannot follow named notation. Okay, so this is about parameter mapping techniques. Okay, so is it clear till here? Okay, I'm stopping the session here. In the next session, we'll learn types of parameters. Next topic is types of parameters. There are 3 types of parameters are there, like in parameter, out parameter, in out parameters. If we know those things, we know about procedures. Okay, and after that, after explaining these types of parameters, I cover database programming. In the database programming, how can we define the procedures? Number of examples we see. Okay, thank you everyone. See you tomorrow.